Okay, so this is 2022 AMC 10B problem 13. The positive difference between a pair of primes is equal to 2. And the positive difference between the cubes of the two primes is 31,106. What is the sum of the digits of the least prime that is greater than those two primes? And there are A, B, C, D, E, 5 options. Okay, so this problem is just sort of like a plain algebra problem here. So what if we let our pairs of primes, our prime numbers be A and B, where A is larger than B, so A is a larger prime. Okay, so the difference between A and B is equal to 2. So A minus B is equal to 2. And we have a difference between the cubes of the two primes. So the difference between the cubes of the two primes is 31,106. So we have two equations here. So supposedly we can solve the two variables. However, we want to factorize one of these equations so we can substitute the other one in. So we have A minus B, so this should be instinct. So you know that A cubed minus B cubed is supposedly equal to A minus B times A squared plus AB plus B squared. So this is in the AOPS books. I recommend you do the Introduction to Algebra one if you want to know this. So this is A cubed minus B cubed is A minus B times A squared plus AB plus B squared, which is equal to 31,106. So A minus B is going to be 2. So if you divide both sides by A minus B, which is just 2, you have A squared plus AB plus B squared is equal to, so 3 over 2 is going to be 1, 11 over 2 is 5, 11 over 2 is 5, 10 over 2 is 5, 6 over 2 is 3, so that's 15,553. Okay, so you're probably going to ask, how does this make the problem easier? We've got this new equation here with an extra term. So here, right now, we can square A minus B equals 2, so we can just square both sides of the equation, and we get A squared minus 2AB plus B squared is equal to 4. Okay, so we have equation 1 and equation 2. So what if I just subtracted equation 1 from equation 2? Because, right now my main goal here is I want to cancel out, I just want to cancel out A squared and B squared or any other term that I can to figure out A, B in an easy way. So if I just subtract 1 from 2, then I can cancel out my A squared and B squared terms. Okay, so I have my AB plus 2AB is equal to 15549. So my 3AB is going to be equal to 15549. If I divide both sides by 3, AB is going to be 5. So 15 over 3 is 5, 5 over 3 is 1, 24 over 3 is 8, and 9 over 3 is 3. Okay, so A times B is 5183. So A times B is, so A and B are primes, right? So, and we'll know that A minus B is equal to 2. So why don't we just substitute A minus B equals to 2 once again, since just now that strategy proved to be useful. So we have A minus B is equal to 2. We can rewrite it in terms of A. A is equal to B plus 2. So I substitute A equals B plus 2 into AB equals 5,183. So I have B plus 2 times B, which is 5,183. Okay, so now all I have to do is just factorize 5,183. So it's not that easy, but after some trial and error, you know that B is gonna be 71. So you know that A and B are both, so since A and B are both prime numbers and their difference of cubes, so their product is firstly 5,183. You want to find a number that's really close to root 5,183 for B plus 2 times B to be 5,183, right? So we want to find an integer really close to this. So if you just and we know that 70 squared is 4,900. So it's somewhere between 70 and 80. Okay, so if you just try the numbers between 70 and 80, which are prime, yeah, B is 71, and A is 71 plus 2, which is 73. So that's an easy way to factor this out. So you can try multiplying these two together. They do indeed give you 5,183. So A and B are 71 and 73. So what exactly does our question want from us? So it says, what is the sum of the digits of the least prime that is greater than those two primes? So basically I want to find the next prime after 73. So and I want the sum of the digits of that prime. The next prime after 73 is 79. And the sum of the digits is equal to 7 plus 9, which is 16. So my answer here is going to be 16. So I just go back up and I see E is 16, so I just circle E, and I'm done with this problem. Okay, so this problem here, the hard part is that we know A cubed minus B cubed is 31,106. And the hard part here is to factor this out and think about canceling the A squared and B squared terms by squaring both sides of this equation over here, and then subtracting equation 1 from equation 2 to cancel the A squared and B squared terms. And another difficulty is to factor out 5,183. So what we can do is, we know that B plus 2 times B is 5,183. So if B plus 2, so we know that B squared plus 2B is 5,183. So we want to find B squared first. So B squared is probably going to be really close to 5,183. So we want to find an integer that's really close to the square root of 5,183. So we know that 70 squared is going to be 4,900. So 70 squared is really close to 5,183 well, compared to other squares. So you can try numbers that are slightly above 70. And that gives us 71 and 73 as our factorization. So thanks for watching.